One, two, three, funky.
Energy can be defined as the capacity to do work, whether that work would be on a gross scale as raising mountains and moving air masses over continents, or on a small scale such as transmitting a nerve impulse from one cell to another. There are two kinds of energy. It is potential and kinetic energy. Potential energy is energy at rest. It is capable and available for work. Kinetic energy, on the other hand, is due to motion and results in work. Work that results from expenditure of energy can be two kinds. A. It can store energy as potential energy, and B. It can order matter without storing energy. The expenditure and storage of energy is described in one law of thermodynamics. It is the law of conservation of energy. The law of conservation of energy states that the energy is neither created nor destroyed. It may be forms, pass from one place to another, or act upon matter in various ways. In this process, no gain or loss in total energy occurs. Energy is simply transferred from one form or place to another. There may be either two reactions. First, exothermic reaction. When wood is burned, the potential energy present in the molecules of wood equals the kinetic energy released, and the heat is evolved to the surrounding. This is an example of exothermic reaction. Second, endothermic reaction. In this reaction, energy from the surrounding may be paid into a reaction. For example, in photosynthesis, the molecules of the product store more energy than the reactants. The extra energy is acquired from the sunlight, yet there is no gain or loss in total energy. There is also one law in thermodynamics that governs the energy flow inside the ecosystem. This is the second law of thermodynamics, which states that on the transformation of one from kind to another, there is an increase in entropy and a decrease in the amount of useful energy. In this way, when coal is burned into a boiler to produce steam, some of the energy creates steam that performs work, but part of that energy is dispersed as heat to the surrounding air. There are three sources of energy. These three sources of energy account for all work in the ecosystem. These sources are gravitation, internal forces within the Earth, and solar radiation. The last one is significant for ecosystem. The solar radiation, which originates from sun, is the source of energy for life, and is what sets the ecosystem besides the natural system. Due to the unidirectional flow of energy, the behavior of energy in the ecosystem is called the energy flow. From the energetics point of view, energy flow is explained as A. The efficiency of a producer in absorption and conversion of solar energy. B. The use of the above said converted chemical form of energy by the consumer. C. The total input of energy in form of food and its efficiency of assimilation. D. The total use cost through respiration, heat, and excretion. E. The gross net production. Every ecosystem has several interrelated mechanisms that affect human life. These are the water cycle, the carbon cycle, the oxygen cycle, the nitrogen cycle, and the energy cycle. While every ecosystem is controlled by these cycles, each ecosystem, its abiotic and biotic features are distinct from each other. All of the functions of the ecosystem are in some way related to the growth and regeneration of its plant and animal species. These linked processes can be depicted as the various cycles. These processes depend on energy from sunlight. During photosynthesis, carbon dioxide is taken up by plants and oxygen is released. Animals depend on this oxygen for their respiration. The water cycle depends on the rainfall, which is necessary for plants and animals to live. The energy cycle recycles nutrients into the soil on which plant life grows. Our lives are closely linked to the proper functioning of each cycles. If human activities go on altering them, humanity cannot survive on Earth. Precipitation is a vital component of how Earth moves through Earth's water cycle, connecting the ocean, land, and atmosphere. Knowing where it rains, how much it rains, and the character of the falling rain, snow, or hail allows scientists to better understand precipitation's impact on streams, rivers, surface runoffs, and groundwater. Frequent and detailed measurements help scientists make models of and determine changes in Earth's water cycle. The water cycle describes how water evaporates from the surface of the Earth, rises into the atmosphere, cools and condenses into air or snow in clouds, and fall again to the surface as precipitation. The water falling on land collects in river and lakes, soil, and porous layers of rock, and much of it flows back into the ocean, where it will once more evaporate. The cycling of water in and out of the atmosphere is a significant aspect of the weather patterns on Earth. Carbon flows between each reservoir in an exchange called the carbon cycle, which has slow and fast components. Any change in the cycle that shifts carbon out of one reservoir puts more carbon in the other reservoir. Changes that puts carbon gases into the atmosphere results in warmer temperatures on Earth. Oxygen cycle, along with the carbon cycle and nitrogen cycle, plays an essential role in the existence of life on Earth. The oxygen cycle is a biological process which helps in maintaining the oxygen level by moving these three main spheres of the Earth, which are the atmosphere, lithosphere, and biosphere. This biogeochemical cycle explains the movement of oxygen gas within the atmosphere, the ecosystem, biosphere, and the lithosphere. The oxygen cycle is interconnected with the carbon cycle. These are the stages of the oxygen cycle. Stage 1. All green plants during the process of photosynthesis releases oxygen back into the atmosphere as byproduct. Stage 2. All aerobic organisms use free oxygen for respiration. Stage 3. Animals exhale carbon dioxide back into the atmosphere, which is again used by the plant during photosynthesis. Now, oxygen is balanced within the atmosphere. Breathing. It is the physical process through which all living organisms, including plants, animals, and humans, inhale oxygen from the outside environment into the cell of an organism and exhale carbon dioxide back into the atmosphere. Decomposition. It is one of the natural and most important processes in the oxygen cycle and occurs when an organism dies. The dead animal or plants decay into the ground, and the organic matter, along with the carbon, oxygen, water, and other components, are returned into the soil and air. This process is carried out by the invertebrates, including fungi, bacteria, and some insects, which are collectively called as decomposers. The entire process requires oxygen and releases carbon dioxide. Combustion. It is also one of the most important processes which occur when any of the organic materials, including fossil fuels, plastic, and wood, are burned in the presence of oxygen and releases carbon dioxide in the atmosphere. Rusting. This process also requires oxygen. It is the formation of oxides, which is also called oxidation. In this process, metals like iron or alloy rust when they are exposed to moisture and oxygen for an extended period of time. A new compound of oxides are formed by the combination of oxygen with the metal. The element carbon is a part of seawater, the atmosphere, rocks such as limestone and coal, soils, as well as all living things. On our dynamic planet, carbon is able to move from one of these realms to another as part of the carbon cycle. Carbon moves from the atmosphere to plants. In the atmosphere, carbon is attached to oxygen in a gas called carbon dioxide. Through the process of photosynthesis, the carbon dioxide is pulled from air to produce food made from carbon for plant growth. Carbon moves from fossil fuels to the atmosphere when fuels are burned. When humans burn fossil fuels to power factories, power plants, cars, and trucks, most of the carbon quickly enters the atmosphere as carbon dioxide. Each year, 5.5 billion of carbon is released by burning fossil fuels. Of this, massive amount, 3.3 billion tons, stays in the atmosphere. Most of the remainders becomes dissolved in seawater. Nitrogen cycle is a biogeochemical process through which nitrogen is converted into many forms, consecutively passing from the atmosphere to the soil to organism back to the atmosphere. The stages of nitrogen cycle. Process of nitrogen cycle consists of the following step: nitrogen fixation, nitrification, assimilation, ammonification, and denitrification. These processes takes place in several stages.
I think I'm losing my mind, trying to stay inside the line.